so we're at our last lesson for simplifying radical expressions, and we are going to be dividing. So, like steps 1 through 3, really, like kind of happen at like the first thing. You're trying to look and see which one is going to work best for your radical expression here. So you can break apart the radicand. So you can, if it has a square root of a divided by b, that's the same thing as the square root of a divided by square root of b. Likewise, if you have the square root of a divided by square root of b, it's the same thing as the square root of a divided by b. So it kind of goes, that equal sign goes both ways. You want to look for perfect squares and simplify them, or you want to simplify / divide and reduce the radicands if possible. So that's one of the first things you want to look at when you're trying to do this. So let's take a look, and we're just going to work through some of these. I'm going to go ahead and tell you up front, right now, you're not going to have any square roots in the denominator. Stay there, okay? So if you end up with a radical expression in the denominator, you want to make sure you go back and check your work, because that ain't going to happen, because then you have to do something else. And a time in virtual learning just ain't the time to be doing that. So we're going to look here. So again, no radical signs in the denominator that stay there. They'll always divide out or simplify out. So we have the square root of 49 over 100. So that's the same thing as the square root of 49 divided by the square root of 100. Now, these are both perfect squares. So the square root of 49 is 7, and then the square root of 100 is 10. And then that's it, okay? So 7/10. Make sure at the end you would reduce that if it kind of came out to be that way. So you look here. So on this one, I don't have a perfect square. So if I were to split this up as a square root of 8 divided by the square root of 32, that's not going to help me. That's why I'm telling you that it's important for you to go through and kind of decide which one you want to do first. So that doesn't help me. So what does help me is to simplify that. So this really becomes a square root of 8 divided by 32. That simplifies to be 1/4 if I divide both of these. I'm going to divide this by 8 and divide this by 8. So I have the square root of 1/4, which then that does equal the square root of 1 divided by the square root of 4. The square root of 1 is 1. The square root of 4 is 2. So you end up with 1/2. So again, like the first step that I went to in number 1 was that go ahead and split it up because I had perfect squares. But the first step that I did on number 2 was to divide inside the radical expression. So here I can't simplify within 3 and 16. There's no number that goes into both of those. So I'm going to go ahead and split it up and see what that looks like. So if I have the square root of 3 divided by the square root of 16. So I could leave it as a square root of 3 over the square root of 16, which is just a positive 4 there. So that's what we're left with. All right, so again, it kind of sort of depends on what you want to look for. So I would probably always simplify and divide first, then go back through and find your square roots there. Okay, on example 4, so I have the square root of 96 divided by the square root of 3. So I think I could go ahead and write this as the square root of 96 divided by 3. So I'm going the opposite way. Then I can divide. So this would be the square root of 32, which has a perfect square in it, which is 4. So the square root of 4 times the square root of 8, which makes 2 square root of 8. So I went from here to here because I divided 96 divided by 3 gives me 32. Then I simplified from there. Okay, we're going to do the same thing here, even though we have a coefficient. So this is really like 7 times the square root of 108 over 6. Okay, so this is really 7 times the square root. I'm going to go ahead and divide that 108 divided by 6, which is going to be, 18, sorry. 18, there's a perfect square in 18, so that's going to be the square root of 9 times the square root of 2. We still have 7 out here in front. So the square root of 9 is 3, so I have 7 times 3 times the square root of 2. These two multiply together to give me 21 square root of 2. So there's our solution there. So again, I think it's easier to go ahead and divide there. Okay, so same thing here. This is going to be 3, and I'm going to the square root of 5 divided by 45. Now, this isn't make a nice pretty number just yet. So that's just going to be 3, and then this is going to be the square root. I can reduce what's inside of there. So it's not 45 divided by 5. It's 5 divided by 45. So this is going to be 1/9, which then makes 3 times the square root of 1 divided by the square root of 3, square root of 9, which is 3. So then I have 3 times 1 over 3 once I find both of those square roots, which actually ends up being 1. Isn't that crazy? All that work to find out 1. I would probably venture to guess numbers 4 and 5 will be like most of your questions on their skill check, as well as numbers 1 and 2. Okay, so you'll either have a nice pretty number or you'll have a coefficient and a square root, okay, on your skill check there. So again, you're just going to be filling in those just like you have been the previous times now. So this is it. This is the dividing piece of it. Again, there's a little extra piece to the dividing part because if you have a radical sign in the denominator, you have to do something else to not let that be there. So, but we're not going to go there for right now because you just don't have as much access to me as you would with me being in the classroom. So this is it for the radical expressions. We're going to do a couple of like review things throughout the week, the following weeks, and then I think that'll be it. Reach out to me anytime. We're going to have our, reach out to me as far as Schoology messages or any kind of Schoology conference if you have any questions there. All right, that's it.